So, hello everyone. I hope my voice is clear to you,
Yes, ma'am.
and my screen is visible.
Yes.
Okay, we'll wait for 5 minutes. Then we'll start the session as I'm expecting some more students to join. So just wait for like 4 to 5 minutes, then we'll start the session. Okay, so we'll start the session. So first of all, let me introduce myself. My name is Imanshi Singh. I'm currently a research scholar at Department of Mathematics, IIT Jodhpur. I'm pursuing my PhD in broad area of probability and statistics. Okay, and I'm your TA for the course Regression Analysis, which is taught by Professor Soman Methi at the SWAM portal. So this is our third live session. Okay, this is the live session schedule. So we have completed two live sessions in last 2 Mondays, and this is our third live session. And this live session, we have these live sessions for the class on every Monday from 6 to 8 p.m. Apart from this, these are the important links. And first one is the Google Meet link by which you can join the class. Second one is the link to my channel, so where you can find all the recordings of the live sessions. Okay, the third one is the Google Drive link where I'm uploading all the PowerPoint presentations in order to provide you the content which I teach in the during the live sessions. Okay, I hope these things are clear. In every session, I just inform you about these things so that the things are clear to you. Okay, the plan for the live sessions are basically we first of all discuss the topic which has been covered in the lectures briefly. Then we just go for the practice examples, and then if any one of you have any doubt, then you may ask that. Okay, so now I hope that these things are clear to you and you have watched the week 3 lectures because I will be giving a brief recap about about the content which is taught in week 3. Okay, then we'll go towards the questions. Okay, uh, I just expect that you people have watched the lectures because otherwise it will be a little tough for you to get the things because I will just give a brief um, recap. Okay, so in the previous lectures, we were discussing about a simple linear regression analysis. In the last lecture, uh, uh, we studied a little about the multiple linear regression analysis, for which I have given the motivation that in place of only one regressor variable, if we have more than one regressor variable, then what we can do, how can we fit that model, how can we estimate the corresponding parameters. So for that, the model is given by this y is equals to beta naught plus beta 1 x1 till beta k minus 1 xk minus 1, where these x1 x2 xk minus 1 are the regressor variables, and we have beta naught till beta k minus 1 k parameters and k minus 1 regressive variables. Now here we can represent this in a matrix form like y is equals to x beta plus epsilon, where this x is a this is a k cross k n cross k matrix, and here this is a k cross 1 matrix. Okay, and here this is a n cross 1 matrix. Okay, and this is n cross 1 matrix. Fine. So all the observations can be represented in this way, and further the estimate of the parameters are obtained by this. So beta it is x transpose x whole inverse x transpose y. So just find out this matrix x. Just find out this quantity, then x transpose x inverse x transpose y. Once this is we are able to find this, all the so it will be a vector. The beta hat, it will be a vector of k cross 1. So it will be a like beta naught hat till beta k minus 1 hat. So it is a k cross 1 vector. So this will be the estimates of the parameters. Okay, and we had these conditions. We have this one k conditions or the constraints on the residual. So that's why k degrees of freedom are lost. So the SS residual has n minus k degrees of freedom because of this. So we have discussed all this. That's why I'm just going a little fast. Here, these are the statistical properties of beta hat. Like this is an estimator, which is an unbiased estimator of beta. Variance of beta hat was sigma square x transpose x inverse, and we also found that ms residual, which is ss residual by n minus k, this is an unbiased estimator of sigma square. And so if I want to find out the estimate of the variance of beta height, then in place of this sigma square, I'll just use the MSRES x transpose x whole inverse. So this will be the estimate of the variance of beta hat. Okay, so it will be a variance covariance matrix. So it will be a variance covariance matrix. So it will be a k cross k matrix. Okay. Further, the SS regression, these are the forms by which we can find these quantities, and other forms are like SS residual can be found out using summation of EI square. SS total, this can also be written like YI minus Y bar whole square. And by using these two, we can find the SS regression using the using the equality SS regression plus SS residual is equals to SS total. Okay, so these things we have already discussed. Now Further, we want to see, so like if I have this model, y is equals to this one, so I want to see that whether there is a linear relationship exists between the dependent variable y and independent variables x1, x2, x till xk minus 1, whether any linear relationship exists or not. For that, we discussed a test. So the in week 3 lectures, this test was discussed basically. So this is the test of significance of regression model, which basically tells about that is there any linear relationship between the response and any of the regressor variable. Okay, so for that, we what is the hypothesis that beta 1, beta 2 till beta k minus 1 is 0 versus h1, which is beta j not equals to 0 for at least one j. So that is which is saying that the alternative is saying that at least one of the beta j is non-zero, means there is a linear relationship of between y and one of the regressor or at least one of the regressor variable. Okay, if all of them are zero, means there is no linear relationship. Okay, so this only tells us that whether there is a linear relationship between y and any one of the regressor variable. Okay, it does not tell that which regressor variable basically we are targeting, but it is saying that at least one of the regressor variable is linearly related to y. Okay, for this we have this ANOVA table. Okay, for that we have to calculate the SS regression, SS residual, SS total, and the SS regression has k minus 1 degrees of freedom, which we already discussed. SS residual has n minus k degrees of freedom, SS total has n minus 1 degrees of freedom. Using these quantities, we can calculate MS regression and MS residual, and using that we calculate this F statistics, which is MS regression divided by MS residual. And this basically we reject this null hypothesis if this statistics or this statistics is greater than f alpha k minus 1 n minus k. This can be calculated using the table, and this is the tabulated value from the data. So if this is greater than this, then we reject h naught. So this is basically the test for finding out or analyzing that whether any of the regressor variable and the response variable is linearly related or not. Is it fine or any doubt? Any doubt in this? Okay, so should I move for the next slide? Okay, at least respond in the chat box. Okay, so I'll move forward. So if there is any doubt, then you can ask. Otherwise, I'll move forward. Fine. So I'll. So if now further here we talked about whether every parameter is zero versus any at least one of them is not zero. Okay. What about if we want to test for an individual parameter? So for that, to analyze the significance of a particular exchange presence of other regressor in the model, we test this hypothesis. Basically, what we want to test that beta j is 0 versus h1, that is beta j not equals to 0. So for example, if I have this y is equals to beta naught plus beta 1 x1 plus beta 2 x2. In particular, I want to test for x1, like for beta 1. Like beta 1 is equals to 0 versus beta 1 not equals to 0. I don't want to test for both of them. I want to test individual for beta 1, that whether in presence of beta 2, this beta 1, what basically the significance of the corresponding regressor variable x1 if I want to check. So I will test the hypothesis that beta 1 is 0 versus beta 1 is not 0. So in general, if I want to test any of the individual parameter, then for that we test this hypothesis and we reject the null hypothesis if this statistics is greater than T alpha by 2 n minus k. Here you can see that beta j hat is nothing but the estimate of this beta j. Okay, the least square estimate of this beta j, which you can find from the previous formula which we have discussed. And this is ms residual, which is nothing but ss residual by n minus k, and this is x transpose x inverse minus 1 jj. So it is the, so for example, if I want to test for beta 1, so it will be x transpose x inverse 1 1. So it will be the, so for example, this is a variance covariance matrix, not variance covariance, x transpose x whole inverse matrix. So if this is a like k cross, for example, for this, if it is a 3 cross 3 matrix, so this entry will be this middle entry. So for example, here it is, so this will be the, this will be the uh, for beta naught. Okay, this entry will be for beta 1, and this entry will be for beta 2. So if you want to test for beta 1, then we will use this entry here in place of this. MS residual we will be calculating. Beta j hat we already know from the least square estimates. Then we can take the mod of that quantity and I compare with T alpha by 2 comma n minus k. I'll discuss a question on it. Then it will, the things will become more clear. So is it fine? So this is for the individual regression coefficient. Okay. Now, apart from this, here we were calculating for the individual coefficient. Now, if I want to analyze that significant, if I want to analyze the significance of some subset of regressor. So, for example, I have k minus 1 regressors. Okay, x1 till x k minus 1. Now, I want to see that whether x2, x3, these two are significant or not. Basically, I want a subset of it to check that whether these two are significant or not. Okay, now for that, what I will do, I will check that in the hypothesis H naught, that here the coefficient of x2 is beta 2, the coefficient of x3 is beta 3, for example. Then in H naught, I will say beta 2, beta 3, this vector I am talking about, this is 0 or h1, that beta 2 beta 3 is not 0. So this is just an example, but in general, so here I have written, because here I have taken a particular values that x2 and x3 are significant or not, but in general if I want to write, okay, then in place of these particular quantities, we just, what we do, we basically, so we have this vector beta 1 beta t beta 2 till beta k minus 1. So these are the coefficients of the regressors, or we can say the parameters. Now we just partition these parameters into two kind of subsets. So one is beta 2 r cross 1 vector, and other is beta 1 k minus 1 r minus 1 cross 1 vector. So this consists of k minus 1 minus r parameters, and this consists of this beta 2 consists of r parameters. So we are basically saying that we want to check whether this vector beta 2, which consists of r parameters, so this vector is 0 or not. Okay, so that's why we have considered this hypothesis, or we will test this hypothesis that beta 2 is 0 versus beta 2 is not 0. Okay, now for that, we'll just calculate the regression SSRES and SSREG. So now for this, so for example, if I take this, for this example, if I take, so for this, our full model will be the full model where I'm considering y is equals to x beta, and we will calculate the SS regression, we can calculate the SS residual. Okay, but if I consider the restricted model, now for restricted model, this beta 2 and beta 3 are 0. Okay, now for that I will consider the value x1. Okay, I'll not consider value x2 x3, I will consider x4. For example, this was till x7. Then I'll consider x5, x6, x7 and y. Now I will consider these observations. Now using these observation, I will calculate the SS regression for the restricted model. Then I will use that value here, and for the full model, I will use these values, and then I will just compare it with this f alpha r comma n minus k. Now because we have considered these two variables to be, so vector of length 2 cross 1 to be 0. So that's why in place of r in this case will be 1 2. So alpha 2 will be here. So this will be alpha r, in place of r it will be 2. N was what? So, and I don't know what is n. So that will be the number of observations minus what is k. So k is the number of parameters. So since we have 7 regression coefficient, we'll have 8 parameters. So n minus 8. Okay, so in this way, we'll calculate this statistics and conclude if we reject the null hypothesis, then we'll conclude that at least one of the regressor in the beta 2. So for example, for this example, if I get that that f is greater than this, so basically we reject h naught, then we are basically saying that in x2 or x3, any one of the at least any one of the regressor is having a significant effect, or have a significant relationship, linear relationship with the response variable. Okay, and if we are not able to reject the h naught, then we'll say both x2 and x3 are not a very significant regressors. So is it fine, or is there any doubt? Is there any doubt? Okay, so if there is no doubt, then we'll move for the next one. So that is basically the confidence intervals. Now, the first one is the 100 into 1 minus alpha percent confidence interval for the parameter beta I. If I want to find out the for parameter beta I, if I want to find out the confidence interval, then the confidence interval will be this way. So this is beta I hat, which we can find out by fitting the linear regression line. Oh, sorry, not line, the linear regression, multiple linear regression model. If we fit it, then we can find out the beta I hat. T alpha by 2 comma n minus we can find out using the table. MS residual, that is y minus y hat summation whole square. X transpose X inverse I. So it will be that entry. So corresponding to that beta I. So if I have X transpose X, that I already explained, inverse this to be in matrix. And if we are taking this to be beta 2 head, so it will be 2, 2 here. So if this is a 3 cross 3 matrix, so this will be this entry corresponding to beta 2. Okay, so that will be this entry, and similarly we can take the sum of it. So this will be the confidence interval for the parameter beta I. And if I want to find out the confidence interval on mean response at point this, then that will be this interval. So here this x naught is the point, so it is a 1 cross k matrix, I can say, or a 1 cross k vector, and beta hat is nothing but the ordinary least square estimator of beta. So it will be a 1 cross 1, so this will be a constant, minus this can be calculated from the table. And similarly, this quantity MSRES is same as this. X naught is this one. X transpose X whole inverse is this matrix, and X naught. So it will be transpose here. So transpose here. Okay, and this will again be a constant. Then we can evaluate the whole thing in the right hand side also. And this will be the 100 into 1 minus alpha percent confidence interval on the mean response at this point. Further, the prediction interval, so for the future observation y naught, at this point, if I want to predict the confidence interval for y naught, then this will be the confidence interval. Other values are same, only difference is here. So we can calculate, evaluate it similarly, the values, and just put it here and just find out the values. Okay, so these are about the confidence interval. So basically, in this all the recap, we basically majorly learned about the multiple linear regression. Okay, where we have estimated the parameters, we have talked about the confidence interval and testing of hypothesis. Okay, in order to check the significance of the different regressors. Okay, so just let me know if there is any doubt. Otherwise, we move towards the questions. Is there any doubt? Okay, fine. So we'll move for the next. So we'll move for the questions now. Okay. So here, and the question is given that consider the observed data given below fit the multiple linear regression model with two regressors in the following data. So here you can see we have two independent variables x1 and x2, and one response variable y. Okay, so we have to take this model y is equals to x beta. Okay, now here what is x in the if we see the table, then x is nothing but, so at the first one it will be 1 1 1 because of the beta naught. So we have 5 observations, so it will be 1 1 1 1 1. Okay, x1 and x2 will be 1 2 3 4 5. Next two is 2 1 3 5 4. So this is our x. Beta is beta naught, beta 1 and beta 2, and y is 6 8 12 17 18. Okay, so is the this is the things, and we know what is beta hat. So beta hat is x transpose x whole inverse x transpose y. Okay, so this is x transpose x whole inverse x transpose y. Now first of all we'll calculate what is x transpose x. So this is 1 1. Okay, sorry. So x transpose is 1 1 1. Okay, so this matrix will be, if I multiply this, so it will be 5. Okay, if I multiply this, it will be 5 4 9 12 15. Okay, if I add this 5 4 9 again 15. Okay, now this entry will be 15 only. This entry will be 15. Okay, now further, this will be 15 again. This will be so what will be the entry here? So it will be 1 plus 4 plus 9 plus 16 plus 25. So it will be 55. Okay, and this entry will be 2 plus 2 4 plus 9 13 plus again 20. So it will be 2 plus 2 plus 9 plus 20 plus 20. 44 plus 9 53. Okay, and this entry will be, okay, so here it will not be 15. This is a symmetric matrix, so here it will be 53. Okay, since it is a symmetric matrix, so this entry and this entry will be same, this entry and this entry will be same. What will be here? So it will be 4 plus 1 5 plus 9 14 plus 25 plus 16. So it will be 55 again. Okay, so this will be the x transpose x matrix. Now I'll just write the inverse directly. because the calculation will be very lengthy. So here X transpose X inverse will be the matrix. Let me write this. So it is 1.2 here. Okay, minus 0.1667 minus 0.1667. Okay, so this is a X transpose X matrix. Okay, now X transpose X inverse matrix. Now we need X transpose Y matrix. So X transpose is 21354 and Y is 6, 8, 12, 17, 18. Okay, so this is the X transpose Y matrix. So what will be the first entry of it? What will just you tell me what will be the first entry of this matrix? So this will be 6 into 1 plus 8 into 1 plus 12 into 1 plus 17 into 1 plus 18 into 1. So what will be the first entry? So what will be the first entry of this matrix? X transpose Y. It is a 3 cross 5 matrix. It is a 5 cross 1 matrix. It will be a 3 cross 1 matrix. Just tell me what will be the first entry here? Just do the matrix multiplication. What will be the first entry? No answer. The first entry will be nothing but the sum of these entries. No? So it will be what? This is 30, 47, 61. So it will be 61. The second one. So you just have to do the matrix multiplication. What will be the second entry? What will be the second entry? Just tell me the second entry and third entry. Just do the matrix multiplication. So just tell me the first, second, and third entry of this matrix. Two one six. The second entry is 216, correct? And the third entry? What will be the third entry? Yeah, correct. 213. Okay, so now we have this X transpose X whole inverse and we have X transpose Y. Now we'll just find out the beta hat. So that is nothing but this matrix X transpose X inverse, this matrix. So that is 1.2 minus 0.1667, again minus 0.1667, and here 1667, 0.2778, 0.222. This is 0.222. This is minus 0.1667. This is and multiplied by X transpose Y, so which is 61, 216, and 213. Now just tell me what will be this beta hat. So here we have 3, we will be having, so here you can see it is a 3 cross 3 matrix and it is a 3 cross 1 matrix. So we'll get a 3 cross 1 matrix where first entry will be beta naught hat, second entry will be beta 1 hat, and third entry will be beta 2 hat. Just tell me what will be the beta naught hat. We have to just do the matrix multiplication. So what will be beta naught hat? And what will be beta naught hat? Anyone? Have you done the calculations correctly? Because here we have this minus sign. Okay, minus sign with us. So these two quantities will be getting added and will be subtracted from the 61 into 1.2. So are you sure that you have done the right calculations? Because here you can see that 1.2 multiplied by 61 minus 0.1667 multiplied by 216 minus 0.1667 multiplied by 213. Okay, so let me calculate it. So it is 1.2 multiplied by 61, so it is 73.2 minus 216 multiplied by 0. Or I can write 0.1667 7 multiplied by, so it is now here 71.5143. Okay, so here this is the whole quantity, whole this whole quantity here, because I have written, so it is 73.2 minus 0.1667 multiplied by, if I add both of them, then it will be 4299. Yeah, so if I multiply both of them, I will get this quantity, and this is the same as this, and this will be equals to minus 1.6857. So I think there is a mistake in your calculation. Okay, so it is 1.685. So yeah, beta hat. So it is 1.6857. Okay, the next value will be 2.55. Okay, and the other one is 1.0507. So now these values will be beta naught hat. This is beta 1 hat, and this is beta 2 hat. Fine. So now our model will be y hat is equals to 1.6857 x1 plus 2.55 x2 plus 1.05 x, not x. So x1 will be here and there x2. Fine. Now so this is y hat. Now for each of the yi, we will find out the yi hat. Okay. So we have this yi 6, 8, 12, 17, 18. So here for each, so here if I want to find out the yi hat, so that will be x into beta hat. So I have to find out the x into beta hat. Okay. So now in this question, I think we have to fit the multiple linear regression model, so which we have already fitted. Okay, so this will be our model. So this will be our model. Fine. So here there is no need to find out the y hat because we have fitted the model. Now in the next question, using the data in question 1, we have to obtain an unbiased estimator of sigma square. And in the theory, we knew that an unbiased estimator of sigma square is nothing but MSRES. Okay, MSRES is an unbiased estimator of sigma square. And what is MSRES? MSRES is nothing but SSRES divided by n minus k. In the data of question 1, we have n is equals to 5 and k is equals to 3. So n minus k will be 2. Fine. And what will be the SSRES? So SSRES is nothing but E transpose E. And what is the E? Is the vector of residuals. Okay, how we can calculate the E? It is nothing but y minus y hat. Okay, now we have to calculate y minus y hat vector. And what is y hat? Y hat is nothing but x beta hat. We know the x vector, we know the beta hat vector. So okay, so x vector is 1, 1, 1, Okay, this is the x vector, and beta hat vector is 1.6857, 2.55, and 1.05. Okay, now this we are calculating y hat. I'll just calculate it and tell me what will be the first entry of this matrix. So this is 1.6857 plus 2.55 plus 2 multiplied by 1.05. So this is 6.3357. Okay. Now this the second one is 1.6857 multiplied by 1, 2.55 multiplied by 2, and 1.05 multiplied by 1. So it is 7.8357. Okay, what about the next one? 1 into this, 3 into the second quantity, 3 into the second one, and 3 into the 1.05. So it is coming out to be 12.4857. Now the fourth one, so 1 into the first quantity, 4 into the second one, and 4 into the third one. So it is coming out to be 16.0857. Now the last one, this is 155. 5 into the second one and 5 into the third one. So it is coming out to be 19.6857. Okay, and you can see that the vector y vector was, so y vector was 6, 8, 12, 17, 18, and here you can see the difference of 6 and 6.3 approximately same, 7.8 and 8, 12 and 12.4, 12 and 17 and 16.08, and 18 and 19.6. So they are very like close to each other. Now we will find the e vector, which is nothing y minus y hat or y hat minus y. You can also consider both of them. You can consider. Okay. So it will be, this vector will be 6 minus, or I can also consider y hat minus y. There is no problem. You can consider any way you want to. 6 minus 6.3, it will be 0.3. Sorry, 6.3 minus 6, it will be 0.3. 7.8. Okay, so I'll just calculate till the decimal places. I'll calculate the opposite quantity. Fine. 6 minus 6.3357. So it will be minus 0.3357. 8 minus 7.8357. So it will be 0.1643. Fine. 12 minus 12.4857. 12 minus 12.4857. So it is minus 0.4857. 17 minus 16.0857. So it is 0.9143. Okay, 18 minus 19.6857. It is minus 1.6857. Fine. Now we have to calculate the SSRES. So now SSRES will be E transpose E. Okay, so it is E transpose is what? Minus 0.3357, 0.1643, 0.4857, 0.9143, and minus 1.6857 multiplied by this matrix. The transpose of it. So this will be equals to this into this square. So means this square plus this square plus this square plus this square plus this square. Okay. So I'll do that. 0.3357 square plus 0.1643 square plus 0.4857 square plus 0.9143 square plus 1.6857 square. So it is coming out to be 4.0531. If there is any mistake in the calculation, then you guys please tell me. Okay, so this is nothing but the SS residual. So MS residual will be 4.0531 divided by n minus k. N minus k was 2. Okay, so it is divided by 2. So it is 2.02656. Okay, so we have to obtain the unbiased estimate of sigma square. So an unbiased estimate of sigma square is 2.02656. Okay, this we have obtained. Now in the second part, obtain the variance covariance matrix of the least square estimator beta hat. So we know that variance of beta hat. What is it? Variance of beta hat. What is the formula if I want to find out the variance of beta hat? What is the formula for variance of beta hat? So that is sigma square. So, wait a minute. No answer. So sigma square x transpose x whole inverse. So that is a variance of beta hat. But in this problem, we do not have the sigma square. So we'll just estimate it. So variance hat, beta hat. So in place of sigma square, we know that MSRES is an unbiased estimate of sigma square. So we'll write MSRES in place of sigma square, x transpose x whole inverse. Okay. So this is nothing. So MSRES we have calculated already. So that is 2.026. So it is 2.026. And here we'll just write this matrix x transpose x inverse. This matrix. Okay, so that will be what? 1.2 minus 0.1667 minus 0.1667. Here minus 0.1667, 0.2778, 0.2778, 0.222, 0.221 minus 0.16. So this is the now if I want to find out here variance of beta naught hat. Okay, so just consider here beta naught, beta naught, beta naught, and here beta beta 1, beta 2, here beta 1, here beta 2. So variance of beta naught hat will be this quantity multiplied by this quantity. So this is 2.026 multiplied by 1.2. Okay, variance of beta 1 hat. So this will be this quantity multiplied by this quantity. Okay, so that is 2.026 multiplied by 0.2778. and variance of beta 2 hat will be 2.026 multiplied by 0.2778. 2.026. So that both are same. So this is equals to variance of beta 2 hat also. Okay, so let me calculate these values because we'll need them afterwards. So it is 2.026 multiplied by 1.2. So it is 2.43. Just give me a minute. Okay. So I will write variance of beta naught hat here. So it is 2.4312 and this is equals to 0.5628 and this is also equals to variance of beta 1 hat. Okay, so this way we can find out this is the variance covariance matrix. If we multiply this quantity to each of the entry, so that entry will be a variance covariance matrix where in the diagonal we have variance of beta naught, variance of beta 1 and variance of beta 2. Not the variance but it is the estimate of the variance. Is it fine? Is it clear or any doubt? Any doubt in this? Okay, fine. So then we'll move for the next question. Okay, so here in the question, it is asked that consider this multiple linear regression model. The observed data is given here. So here in the multiple linear regression, you can see that we have two regressor variable. Okay, and one is a response variable and three parameters we have beta naught, beta 1 and beta 2. The data consists of 4 observations. Okay, for x1, 4 observations for x2 and 4 observations for y. I have to fit a multiple linear regression model to the data using the ANOVA approach. I have to test whether there is a significant linear relationship between the response variable and explanatory variables at 5% level of significance. So basically, first of all, I have to fit in multiple linear regression model to the data. And then by using the ANOVA approach, which we have discussed, we have to test that whether there is a significant relationship, linear relationship between the response variable and the explanatory variables. So basically, we do not have to check individually for variables, but we have to for parameters, but we have to check that whether there is a linear relationship or not. So basically, we have to test the hypothesis H naught that beta naught is equals to beta 1 is equals to beta 2 is equals to 0 versus the alternative that at least 1 is 0 is not 0. Okay, I'll write it clearly, more clearly in the next page. Is first of all, we'll just go and find out the, first of all, we'll fit the basically the multiple linear regression model to the data. So we have the value, the observations for x1, we have the observation for x2. So we'll just first of all construct the matrix X. So that matrix will be 1, 1, 1, 1 because there are 4 observations, 1, 2, 1, 2, and 1, 1, 2, 2. Okay, Y we have 4, 5, 6, 8. Fine, beta is beta naught, beta 1 and beta 2. So what is now X transpose X? So here we have 1, 1, 1, 1, 1, 2, 1, 2, 1, 1, 2, 2 multiplied by X. So this matrix, what will be this matrix? This matrix will be, so this matrix will be So this matrix is 4, 6, 6, 6, 6, 10, 9, 9, 10. So this is the X transpose X matrix. I'm writing this because otherwise it will be very lengthy. If there is any doubt or anything, we will just discuss it. Okay. Now what will be X transpose X inverse? So we can find out the inverse, and the inverse will be 4.75 minus 1.5 minus 1.5 minus 1.5 here minus 1.5 here. 1, 0, 0, 1. So this is the X transpose X inverse. Okay, now what is X transpose Y? X transpose is 1, 1, 1, 1. And Y is 4, 5, 6, 8. So this is nothing but, so it is 23, 36, 37. Fine. Now we need to calculate the beta hat. Okay. So that is X transpose this matrix multiplied by this matrix. X transpose X inverse multiplied by X transpose Y. So this matrix multiplied by this matrix. So let's calculate this. So I have to calculate this. 4.75 multiplied by 23 minus 1.5 multiplied by 36 minus 1.5 multiplied by 37 minus 0.25. Okay. Now second one is minus 1.5 multiplied by 23. And 0 into 37. So there is no rule of 0 here. So it is basically 36 minus 1.5 into 23. So it is coming out to be 1.5. Okay, now here next one is 37 minus 1.5 multiplied by 23. So it is 2.5. Okay, so this is beta naught hat, this is beta 1 hat, and this is beta 2 hat. Now we have calculated the estimates of the parameters. So the model will be y hat is equals to beta naught hat is minus 0.525 plus 1.5 x1 plus 2.5 x2. Okay, now what we have to calculate? We have fitted the model and we have to find out the significant linear relationship. For that, for the ANOVA table, let's make the ANOVA table. So here let us write regression. This is residual and this is total. So SSREG we need to calculate, SSRES we need to calculate. Okay, and here degrees of freedom, and here F. Fine, or here SST. So for the SST, we need yi minus y bar whole squares, and for SSRES, we need yi minus y hat, summation of yi minus y hat whole squares. Okay, so let us write the entries in a page. Okay, so let us write these entries here. So So the model is minus 0.25. Write this. Okay, so we'll write the extra y hat we have to find out. So basically, y hat is equals to x times beta hat. Fine. So now x is, we know what is x. X is 1 1 2 1 2 1 1 2. And what is beta hat we got? 0.25, 1.5 and 2.5. Okay. So what will be the y hat then? So it will be the sum 2.5 plus 1.5. So that is 4 minus 0.25. So it is 3.75 here. Okay. And this is 1.5 multiplied by 2 plus 2.5 minus 0.25. So it is 5.25. It is 6.25. And next one is 7.75. So this is y hat. Okay. Now y minus y hat. So what are the values of y? Y was 4, 5, 6, 8. 4, 5, 6, 8. 4 minus 3.75. 0.25. 5 minus 5.25. Minus 0.25. 6 minus 6.25 minus 0.25. 8 minus 7.75, 0.25. Okay, and what is MSRES? So that is E transpose E. So that is nothing but 0.25 square plus 0.25 square plus 0.25 square plus 0.25 square. So this is 4 times. Okay, so 0.25 square multiplied by 4. So it is 0.25 only. So MSRES is coming out to be 0.25. Okay. Further, we need to calculate the SS total. So that is yi minus y bar whole square summation of. So what is y bar here? If I want to calculate, so y bar is 4 plus 5 plus 6 plus 8 divided by 4. So that is 5.75. So yi minus y bar here will be 4 minus 5.75 minus 1.75. 5 minus 5.75 minus 0.75. 6 minus 5.75, 0.25. And 8 minus 5.75 is 2.25. What is yi minus y bar whole square? 1.75 whole square is 3.0625. 0.75 square, 0.5625, 0.25 square, 0.0625 and 2.25 square 5.0625. Just add them. It will be plus 0.0625 plus 0.5625 plus 3.0625. It is 8.75. So yi minus y bar whole square, so it is 8.75. So MSSS regression will be 8.75 minus 0.25. So it is 8.5. Okay. Now degrees of freedom for the regression term is k minus 1. For the residual it is n minus k, and for this it is n minus 1. So k we have 3. Okay. So 3 minus 1 is 2. N minus k, we have 4 observations. K are 3. So 4 minus 3 it is 1. N minus 1 is 3. Okay. So our MS regression divided by MS residual will be 8.5 divided by 2 divided by 0.25. So what it will be? 8.5. It is coming out to be 17. Okay, so this is coming out to be 17. This is the tabulated value of f, and what will be f alpha 2 comma 1. So f alpha is 0.05. Okay, so here in the table if I see f alpha 2 in the numerator and 1 in the denominator, so this will be the value. So this is 200. So this is 200. Tabulated value is 17. So f tabulated value is less than f alpha 2 comma 1. So we fail to reject H naught. Okay, what H naught was? H naught was, so basically we considered the H naught. H naught was that so we failed to reject H naught. That implies there is no significant proof to say that the response variable y is linearly related with any of xj. Okay, so this we can say using this ANOVA table, and using the, here we have used the, Yeah, so we have used the ANOVA table and we have concluded that there is a no significant proof to say that there is a linear relationship. Fine, is there any doubt? Is there any doubt? Is there any doubt? Or otherwise we'll move for the next question then. Okay, so then we'll move for the next question. So in this question, it is asked that for the data in question 1, test at 5% level of significance that whether the variable x2 contributes significantly to the model after x1 has already been included in the model using the t-test as well as using extra sum of squares. So we have to calculate that whether the x2 variable x2 contributes significantly. So we have the model where we have two regressor variables and one response variable and three parameters. Okay, so basically we have this y hat which is equals to beta naught hat plus beta 1 hat x1 plus beta 2 hat x2, which we have already fitted in the question number 1. Okay, we had the values of beta naught hat, we had the values of this beta 1 hat and beta 2 hat. So let me write that first. So what was the values of beta naught hat, beta 1 hat and beta 2 hat? So it is y hat is equals to 1.6857 x1 plus, not x1, plus 2.55 x1 plus 1.0507 x2. Fine. So this was the model we have fitted in. So okay, so we have for using the t-test, we have to calculate that whether the x2 contributes significantly to the model or not. So basically we want to calculate we have to test the hypothesis that beta 2 is equals to 0 against the alternative that beta 2 is not equals to 0. So using the t-test, what was the t statistics? So t statistics was beta 2 hat divided by under root of MSRES x transpose x whole inverse 2 2. Okay, so this was the test statistic. Fine. And what was the x transpose? So what is first of all the x transpose x inverse, this entry, and what is MSRES? The MSRES we have already calculated. So the MSRES was coming out to be, let us see in the previous example. So first of all, let us write here beta 2 had to be equals to 2.55. So beta 2, not 2.55, 1.507. 1.507. Okay. And what is MSRES? And what is X transpose X inverse 2 2? So this is the entry corresponding to beta 2. Okay, now let us see what was the entry in the matrix. So here in this example, so the entry was 0.2778. Okay, and what was the MS residual? So that we have calculated in second question. So MS residual was coming out to be 2.02, 2.026. So 2.026, and this entry was 0.2778. So we'll just calculate the t here. T is equals to 1.507 divided by under root of 2.026 multiplied by 0.2778. Just calculate this value. It is coming out to be 2.008. Is it fine? Is it fine the way we have calculated the t statistic? 2.008. Fine. Now in this hypothesis, we first of all calculate the t alpha by 2 comma n minus k. N is how much? 5. K is how much? 3. So it will be 2. So t 0.025 comma 2. What is the value for t table for t degree 2 degrees of freedom? 0.025 for 2 degrees of freedom, we have 4.303. So this is less than this. So t is less than t alpha by 2 comma n minus k. Okay, so if it is greater, then we reject h naught. So here also we fail to reject h naught. Okay, that implies we fail to reject h naught means we cannot reject this fact basically. Okay, so we have to basically accept this fact that beta 2 is 0 means there is no significant contribution of regressor x2 in presence of x1. Okay, that implies there is no significant contribution of x2 in presence of x1. Fine. Now in the second part, we have to again do the same thing using extra sum of squares. Okay, so for that, again, we have the full model. We have calculated everything for the full model. Now we will calculate everything for the restricted model. And restricted model will be the model where beta 2 is 0. So basically for that, we have the observation x1 and we have the observations for y. We have to again fit the linear regression model to it. Okay, so we'll do that and we'll use the method of extra sum of square and in order to find out the same thing. So for B part, okay, beta 2 is 0. Okay, so now x1, so this is the restricted model we are talking about. Okay, so the values of x1 and we have the values of y. So let us see what is the value of x1. So let me write it. The values of x1 are 1, 2, 3, 4, 5. Okay, the values of y 6, 8, 12, 17, 18. Okay, so for that we have to calculate the for the restricted model, we have to calculate the SS regression for the restricted model. So for that we have to calculate the SS residual for this model, and for that we have to first of all estimate the parameters for the model. So we have to estimate y is equals to beta naught plus beta 1 hat x1. We have to find this model again for this observations. Okay, so for that what we have to do, first of all we have to calculate the sxx and sxy. Okay, so here let us only consider this to be x. Okay, so we have to calculate the xi minus x bar, yi minus y bar, and their product. Okay, so what is x bar? What is y bar? Just tell me. It is coming out to be 3. $12.2. Now xi minus x bar. 1 minus 3 is minus 2. 2 minus 3 is minus 1. 3 minus 3 is 0. 4 minus 3 is 1. 5 minus 3 is 2. Yi minus y bar. So 6 minus 12.2. So 6 minus 12.2 minus 6.2. 8 minus 12.2. This is minus 4.2. 12 minus 12.2. So this is minus 0.2. 17 minus 12.2. 4.8. And 18 minus 12.2. So it is 5.8. Their product. So 6.2 into 2. 12.4. And this is 4.2. This is 0. This is 4.8. And 5.8 into 2. 11.6. Okay, so SXY will be sum of this. So this is 12.4 plus 4.2 plus 4.8 plus 11.6. So this is 33. Now we want xi minus x bar whole square. Okay, so xi minus x bar whole square will be what? So it will be 41014. So xi minus x bar whole square. And also yi minus y bar whole square for SS total. So xi minus x bar whole square, it is 41014. And this is square, 6.2 square, 4.2 square, 6.2 square, so it is 38.44. 4.2 square is 17.64. And what is happening? Xi minus x bar square. Six point two square. And 0.2 square, so this is 0.04. and this is 4.8 square, 4.8 square, so this 23.04, and 5.8 square, 33.64. So SXX is 4, 4, 8, 9, 10, and SYY is, so this is summation yi minus y bar whole square. So this is nothing but SS total. So this is, let me add it, 38.44 plus 17.64 plus 0.04 plus 23.04 plus 33.64. So it's 112.8. Okay. Now, since we have now found out the Sx and Sxy, so beta naught hat and beta 1 hat. So beta 1 hat is Sxy divided by Sxx. So what is Sxy? 33. Sxx is 10. So it is 3.3. This is y bar minus beta 1 hat x bar. So what is y bar? 12.2 minus beta 1 hat is 3.3 and x bar was 3. So it is 12.2 minus 9.9. So it is 2.3. So the model is y is equals to 2.3 plus 3.3x. Okay, so now we will find out the y hats. Okay, so yi and here yi hat. So what were the values of yi's for it? So 6, 8, 12, 17, 18, 6, 8, 12. Okay, so what is y1? So here we'll just put these values for x. Okay, so it is 2.3 plus 3.3 into 1. So it is 5.6. And in place of 1, then we'll take 2. So it is 8.9. It is 12.2. It is 15.5. 18.8. So yi minus yi hat. So it is 6 minus 5.6, 0.4. 8 minus 8.9. 3 minus 0.9. 12 minus 12.2 minus 0.2. 17 minus 15.5. So it is 1.5. 18 minus 18.8. That is minus 0.8. And yi minus yi hat whole square. So it is 0.16, 0.81, 0.04, and 1.5 square, 2.25, 0.64. We'll just add them now to find out the SS residual for the restricted model. Okay, so it is 0.16 plus 0.81 plus 0.04 plus 2.25 plus 0.64. So this is coming out to be 3.9. And SS total for the restricted was summation yi minus y bar whole square. So whether we have calculated it or not? Yeah, so we have calculated it. SYY. So it is 112.8. So for the residual we have calculated, restricted we have calculated. So regression will be SSREG for the restricted one will be difference of these two. So 112.8 minus 112.8 minus 3.9. So it is 108.9. Okay. So it is 108.9. So this is for the restricted one. For the full, we have already with us the quantities. Okay, so the statistic is now what? So the F statistic is nothing but SS regression full minus SS regression restricted divided by R, which is 1 here. Okay, and whole divided by SS residual full divided by N minus K. N is 5, K is 3, so it is 2. Okay. So now here we'll just put the values. Okay. So SS residual for the full. Let us see in the first example. We have calculated the SS residual. For the question 1, we have calculated the SS residual and which was 4.0531. 40531 minus SS regression. Okay, so this is regression, not the residual. So it will come here 4.0531 divided by 2 minus as the regression for the restricted is 108.9. Okay. And we have to calculate the SS regression for the full model also. So here we have calculated for the data 1. We have only calculated the MS residual. We have not SS residual. We have not calculated the SS regression actually. So that we will calculate. So for that we have to calculate the SS total also. So these are, where are the values? This. So this is the value. So let us calculate the yi minus y bar. Okay, so the SS total will be same for both of them. SS total will be same because that does not depend on the values of xi. So SS total is same for both of them. So that's why we will just calculate now. So SS regression for the full will be SS total minus SS residual for the full. And SS residual for the full is 4.0531. And what is SS total? SS total is, so SS total is for, it is not special for restricted, it is always there. So it is 112.8 minus SS residual for the full. So what is SS residual for the full? It is 4.0531. Okay, so it is 112.8 minus 4.0531. So it is 108.74. Okay, so now then we will calculate the IF statistic. Okay, and here we can see that this statistics is coming out to be negative. Okay, so that we will be calculating. So let us calculate that. So 108.74 minus 108.9. So it is coming out to be 0.07. So I think there is some mistake in the calculation because this cannot be negative. There may be a little kind of a round off thing is there. So you just verify the calculation. The method is fine, but only there is a problem I think in the calculation of these quantities. So just verify it should be positive. Okay, however, it is not coming out to be positive here, but it should be positive. Fine. So the F statistics will be calculated here like that, and then we have to compare it with F alpha, the n r comma n minus k degrees of freedom, and that value can be calculated from the table, and we can just compare. You just verify the calculation and just see that what basically is happening, like different in the calculations, the because of which we are getting it this quantity to be negative. So this should be positive actually. So you just check about it. If there is any uh, doubt in it, then I'll just clear it. If like other than the calculation, there is some mistake in the calculation, that's why this value is coming out to be negative. Okay, fine. So we'll just discuss the last question now. Just I'll write check the calculation here. I'll write calculation of question 4. F should be positive. Okay, then take the decision. Fine, the method is correct, only there is a problem within the calculation. Now yes, in the for the data model, data and the model given in question 1, we have to find the 95% confidence interval for the parameters beta 1 and beta 2. Okay, so the what is the confidence interval for the parameters beta 1? So that is beta 1 hat plus minus t alpha by 2 comma n minus k square root of ms res x transpose x whole inverse 1 1 for the beta 1. Okay, so what is ms res? We already have seen. What is ms res? For the question 1 that we have calculated in question 2. So MSRES was coming out to be 2.02. Okay, so it is coming out to be 2.02, and so yeah, so plus minus. So this is 2.02. Okay, and this x transpose x inverse entry. Okay, just a minute. Let me see the matrix. So that was 0.2778. Okay, and this t alpha by 2 n minus k. So alpha by 2 is 0.025, n minus k is, so n is 5, k is 3, so that is 2. So that is 200. Okay, so this is 200 here. And what was beta 1 hat? Beta 1 hat was 2.55. So this will be the confidence interval for beta 1. Okay. Now for beta 2, it is beta 2 hat plus minus. This is 200 only. And this is 2.02 only. And this entry is same, 0.2778. And beta 2 hat was 1.0507 plus minus 200 square root of 2.02 multiplied by 0.2778. Okay, so this is the confidence interval for beta 2 hat. Fine. Now for the next one, we want prediction interval for the future observation at point 135. So the 95% prediction interval is given by, so what is the formula for it? So formula is x naught beta hat plus minus t alpha by 2 comma n minus k square root of ms res. Okay, 1 plus x naught x transpose x inverse x naught prime. Fine. Now x naught is that is given in the question 135. Okay, Beta hat is we have this 1.685, 2.55, 1.0507 plus this value is 200. So this is plus minus square root of what is MSRES? 2.02. Okay. Multiplied by 1 plus what is x naught? 135. Okay. So you just, I'll write it as it is here. Okay. Now this quantity, how can we calculate it? So it is 135. Fine. And this here x transpose x matrix. So that is 1.2 minus 0.1667 minus 0.1667, 0.2778, 0.2778 minus 0.222. Okay. And here write x transpose 135 x not transpose. If you calculate this, okay, you will get a 1 cross 1 constant. 1 cross 1 matrix basically. So this is a constant, this is a constant, just multiply it, and this will also become a constant. So in this way we can find out the 95% prediction interval. I hope this is clear. Okay, so if this is clear, then just let me know if there are any doubts regarding any question. Otherwise, we'll end this session. Any doubts? Okay, so there is no doubt. If there is no doubt, then let me please inform you that recording for the today's session will be uploaded on YouTube. Presentation will be uploaded on the Google Drive. Okay, and the last day to submit the assignment is this 12th of August, and the next week session will be on 17th of August from 6 to 8 p.m. Okay, if there are any doubt, then you may please ask. Otherwise, we'll end the session. Okay, so if there is nothing, then we'll end the session. Thank you guys for joining. Let's meet on next Monday.